All right, good morning, everybody, or good afternoon, wherever you're joining us from. Thank you for joining us, first off, for our virtual Lamont open house, and specifically this K-12 session featuring a Meet the Scientist session. So my name is Cassie, and I'll be facilitating the session today. I work at the Columbia Climate School, which Lamont-Doherty Earth Observatory is now a part of. And Lamont has had a very long history with open house. We started our open house tradition in 1949 when Lamont's first director, Doc Ewing, wanted to open the campus up one day each year to neighbors, to students, the Columbia University community, and beyond. And we're so thrilled to be offering this session online and reaching new audiences beyond our neighbors immediately within in New York State. And so even now, very few facilities like Lamont, where we are engaged in fundamental and basic science research about our planet, very few institutions like ours are actually open to the community in any way. And we're extremely proud of this tradition. And for over 50 years, Open House has remained one of our most important events, an exciting opportunity for adults and children of all ages to learn about our planet in fun and engaging ways. And it's our way of bringing our science to all of you at home. So today, we are super lucky, and I'm super excited and thrilled to be joined by Dr. Kevin Uno and a special guest. And I'm going to let Kevin introduce that special guest, but Kevin is a Lamont Associate Research Professor, and it's actually one of the scientists featured on a series of collectible cards this open house. Once Kevin has done his presentation, I will share a quick overview of what's included in that packet, but there's a packet that is available to everyone where there's a series of collectible cards featuring our scientists. There's also some activities that you can do at home, and we still have limited quantities available, and we're going to continue mailing those packets out even after open house. So if you are interested, I'm going to drop the link in the chat box. And you can sign up for the packets. And some of you have likely already signed up for the packets as you've signed up for this open house session. So during the session, we're going to actually let Kevin and his special guest kind of facilitate the session, and his special guest will interview the scientists, and we're going to learn a little bit about Kevin's work, how he became a scientist, what his day-to-day looks like. If you do have any questions, additional questions for Kevin, please use the Q&A box. We're going to be monitoring that, and we will definitely have time at the end of the session for interviews or for an additional questions. And this is being recorded, and this will get shared with everybody who's here today. And we're also going to be posting it to our open house website as well as our YouTube channel. So without further ado, I'm going to turn it over to Kevin and our very special guest. So Kevin, whenever you're ready.
Okay, great. Thanks, Cassie, and thanks everybody for joining today. I'll start by introducing my special guest, which is my son, Max Uno.
Hi.
And we came up with this. It was actually his idea. I told him I was doing like a K-12 outreach thing about science, and since he's kind of right in the middle of K-12, figured that he might have good questions and help me answer questions in a way that students out there can understand. So I'm going to turn it over to you, Max, to run the interview. You ready?
Yeah, sure. Right.
Okay.
All right. So let's start off first with like, what is an earth scientist and what do you do? What do they do?
Okay. Let me get the laser pointer going. Okay. That's a great question. I would say if your work involves understanding how the Earth works, whether it's like on land, in the oceans, or in the atmosphere, you're an earth scientist. So the title Earth Scientist covers a really broad range of careers. I've chosen just a few represented here, but there are so many different options. Starting in the upper left here, this is the Perseverance rover that's currently collecting Earth science or geological data from Mars, so it's on another planet. And so a lot of Earth scientists were involved in designing the rover. Like this is a little mini drill that takes samples, and there's all kinds of instruments on there, cameras and things that study the geology of Mars. And so many Earth scientists worked on developing that. And actually some Earth scientists study the geology of other planets. In these next two panels here are careers in renewable energy, and that's a huge growing field and something that's going to be really important in the future. So like anyone working in wind energy or solar energy, and we just need lots and lots of young, bright minds in the future in those fields. And then down here, this is a photo of an environmental consultant, and that's a job I did right out of college for a little while.
Really?
Yeah, we can talk about that. But anyway, they work on cleaning up pollution, spills, things like that, leaks like gasoline. And there's also environmental consultants who like assess an area before they build, say, a skyscraper or a hotel to make sure like there's no endangered species living there. And they also make sure that the ground is stable for building. So environmental consulting is a major job. And then there's lab-based Earth science. It's kind of what I do sometimes.
You
And then,
wear a cool lab coat.
you don't see me in my lab coat, I have one. And then there's people who go exploring, like this is my colleague, Robin Bell in the bottom right, and she studies like ice and ice sheets. And that's a photo of her in Antarctica down on the ice. So many jobs.
Okay, so now that we know about some careers in earth science, tell us about how you found your job. So like, let's start by going back to when you were a kid, like the same age as some of our viewers and also me.
Okay.
So let's start off with like, where did you grow up?
Okay. Well, I grew up in the Pacific Northwest in Washington State, and I was born and raised in the Seattle area.
Okay. So now that we know where you're from, what were you like as a kid? And I have to ask your son, were you nerdy?
As a kid, I was pretty chatty and outgoing, a bit like you, I guess. And I was definitely a bit nerdy, for sure. And one of my first or earliest school memories is playing at the water and sand tables at this Montessori I went to for preschool and kindergarten. So I guess maybe that was an early sign that I might end up as an earth scientist. And overall, I liked school as much as your average kid. My favorite periods were gym class and library, and recess and lunch, if you count those. Yeah.
So what were some of your hobbies as a kid?
Well, as a kid growing up in the suburbs, your Uncle Tony and I spent most of our childhood playing outside in the woods or in the stream behind our house. I played a lot of sports like soccer and basketball. I ran cross country and in the winter would ski. And I think my parents, your grandparents, noticed that their two boys had a lot of energy. So they signed us up for activities that would sort of tire us out. Yeah. And I also played saxophone in school band and did stuff like Boy Scouts.
Okay.
Yeah.
So what inspired you to be a scientist and a teacher?
I became a scientist because winter in Minnesota is so cold. And what I mean by that is, in Seattle, the winters aren't really cold where I grew up. And so when I went away to college in Minnesota, the first winter was so cold and so long. I can't even describe it. So when the spring came, I wanted to be outside as much as possible. And the introductory geology course had an outdoor lab. And I thought, that sounds fun. I like science. I like to be outside. And I think it was after the second week of class, I decided to be a geology major. And I also had an amazing professor, Clint Cowan, who's an exceptional teacher. And I think that really helped kind of draw me into the world of earth science. And I think I eventually fell in love with earth science and became a geochemist because it checked all the boxes for me. The natural world always fascinated me. And I liked learning how things work. As a kid, I would take stuff apart and try to put it back together. And I also liked solving problems. So the Earth is a giant natural laboratory. that's been evolving for 4.5 billion years.
Yeah.
So you can imagine there are so many things to learn, from like how the Earth came to be to how we as humans came to be or evolve on this planet. And here and now in the present and in the near future, we are amidst a climate crisis. So we need lots of Earth and climate scientists to tackle the problems associated with, rising sea level and melting ice sheets and extreme weather events like Hurricane Ida, right, which caused severe flooding and death here in our city. Yeah.
So after college, was your first job as an earth scientist, or were you like, all right, let's be an earth scientist?
Not at first, actually. Right after college, I was an English teacher in Japan, where I taught in junior highs and elementary schools. Here's me doing gym class. Remember, I said that was my favorite class, with some of the junior high kids. And then I taught elementary school English at the community center at night. I also learned judo that year with the junior high kids. But then I moved back to the US and I started graduate school. And even in grad school, I was teaching, but I shifted to earth science. And this is me teaching some earth science to elementary school kids in Salt Lake City.
Yeah.
And then after that, we moved here and I started working at Lamont.
Okay. So now that we know how you became an earth scientist, tell me about like what you actually do. Because to me, it seems like you like lock yourself in your office and write and read emails all day. Is that what you actually do?
Well, I do write a lot of emails. That's true of a lot of adults in the world today. But on a normal day at Lamont, I'd like to go straight to the lab in the morning and kind of check on what's happening. And in my lab, we work on lots of different things. We work on rocks that we collect mostly from Africa and other parts of the world.
Yeah.
And we also look at molecules in modern plants. And these molecules are also preserved in the dirt in which they grow. So we can look at ancient dirt and see these like molecular fossils of plants from the past. And if we analyze plant molecules in this ancient dirt, that also has fossils of like extinct elephants or giraffes or even early humans, our ancestors, we can learn about the ancient ecosystems or habitats that early humans evolved in. And I think you have to remember that early humans didn't have houses or cars, right? They slept outside and they had to deal with hot days and cold nights and rainy days and snowy days without having clothing or buildings to shelter them from the elements. So our ancestors really had to interact and deal with their environment in ways that we don't have to today.
Okay, so I stand corrected, you don't just write emails. How about when you go away to Africa for like weeks at a time? Because all I get is like a couple FaceTime calls and the occasional WhatsApp text.
Right. So it's always really busy when I go to the field in Africa or other parts of the world. But one of my favorite things is to call home to you and see how your day went back here. But when I do go to Africa, I usually go to Kenya, which is a beautiful country in Eastern Africa. And there, sometimes I go to the National Museum, where I study and sample fossil teeth that they have in their research collections. They have thousands and thousands of teeth, fossil teeth. And we use a tiny little dental drill to remove a little bit of the tooth enamel from the teeth. And then we bring it back to my lab at Lamont, where we can analyze the chemistry of the tooth to learn about what the animal ate and what kind of environment it lived in, like whether it lived in a forest with dense tree cover or in a more open woodland with like a mix of trees and grasses, or in a grassland. And if it were in a grassland, I sometimes like to think about early humans that lived there, like they were more exposed out in these open areas to predators. And so our ancestors probably would have lost a race with the lions, if you know what I mean.
Yeah. So, all right, what do you like most about like working out a lot?
Before we jump to that, I'm going to actually just show a couple slides to get a little bit deeper into what I do. Is that okay?
Yeah, that's fine.
Okay. So yeah, I mean, I mentioned that I work on rocks, but also we work on mud from the seafloor, lots of plants and chemistry and teeth. and then also wildlife forensics. And the common theme in all of these things is we can use chemistry to understand the Earth's past. So like some of the main scientific questions that I want to ask or that I work on every day are, how did I get here? And when I mean I mean like humans, us, we as a species, how did we evolve? And a follow-on question is, how did climate change influence human evolution? Like I said, we didn't have like homes and cars and climate control. And so we were really kind of at the whim of climates. And the third question is, why is grass so important for humans? And I think I'm going to dive into that one a little bit because I just love grasslands. And grasslands are like, if you think of the savannas, you know, or even in the Midwest, we have big open grasslands. And they're not very old geologically. They are maybe 10 or 20 million years old, which sounds like a long time. But if you consider the Earth is 4.5 billion years old, grasslands are really, really kind of a new feature on Earth. And I'm going to talk about how we rely on them. And it's kind of a puzzle that they're so new, and yet we, you know, absolutely rely on them. Okay, so why grasses? There are 7.8 billion-ish people on the Earth today. And the fundamental basis of the diet of humans and many other animals is, in fact, grass. So here are three major grasses, wheat, corn, and rice. And this is the amount of grass that, or of that particular crop that is grown in millions of tons. So
corn, there's over 1 billion tons every year?
Every year, yeah.
Wow.
Yeah, we are really a grassy species.
Which means if we've been using corn for like the last, long time, that's
a lot of corn.
A lot of corn.
Yeah. And so, you know, we may not think about our diets as eating like grains of wheat or kernels of corn, but when we look behind the foods we eat, almost all of them are grass-based. So this is your favorite cereal, or it used to be.
Used to be.
Yeah, Lucky Charms. So the little cereal bits are made of like wheat, barley, or oats, I think. But even the little sugary marshmallows, the part you, I think, really like, are made out of corn as corn syrup. I mean, so this whole thing is basically a bowl of grass-derived products. Coke in the US is, you know, sweetened with high fructose corn syrup. So that's mostly grass in a bottle.
Yeah.
The bun of this burger is made of wheat, right? Sesame is, you know, has a seed. And then the beef also comes from grass because cows
they eat it.
They eat corn. Yeah, they mostly are fed corn, yes. And then in other parts of the world, especially Asia, rice is the main staple food. So, you know, for those of you watching, you can just think for a second, like, what did I have for breakfast today? You know, I had yogurt and granola. The grains are from grass, and the yogurt comes from
cows, which eat grass.
Exactly. So even the cream in my coffee. So many of us, you know, whether you're eating eggs from a chicken that ate grains to yogurt, granola, or Mr. Lucky Charms, we are a really grass-based species. And this grassiness in our diet actually goes back millions of years. In fact, we've detected grass in the diets of our ancestors going back 3.7 million years. So some of our earliest ancestors, and we use that again from the chemistry in their teeth. And even in historical records, like this is a painting on a tomb in Egypt.
Like the ancient Egyptians even had.
Yeah, they're celebrating here, or showing, depicting the grain harvest along the Nile. So it's been a very, very long and rich part of our history as a species, and even our ancestors shown here. And this one in particular, this species Parantopus, had like 80 or 90% grass in its diet from what we can tell. Yeah, so it's a really important part of our past.
Okay.
And kind of the big picture, what I try to do is think about climate and the role of environment and the evolution of early humans. So if we think about climate, this upper circle here, okay, probably the easiest way is to think about rainfall. And like in really, really wet, rainy areas, you often get forests. Like in the tropics, you get a rainforest, Costa Rica, the Congo. And those forests have very, very dense vegetation. And in turn, the amount of vegetation, because that's the food, that's like the dinner, what's on the menu, can support a variety of animals, okay? And in the opposite sort of condition or scenario, you could have a desert where it just rains a tiny bit, like the Atacama, right? there's very little vegetation there.
Which means there's very little animals,
It
right?
can't support very many animals. So maybe you find some little like micro mammals like voles or mice or something, but you can't have an elephant living in a desert because there's not enough food around. And so there are strong links between climate and vegetation and fauna and the animals that live there. And so I'm exploring how changes in vegetation over the last couple million years influenced the evolution of humans and their early ancestors shown here. And to kind of take that to a little bit more of a schematic for like maybe the older scientists, the older students, or maybe some of the adults watching, you can also think about it like this. So it's a little bit complicated, but on the left here, you have sort of climate variables. So moisture deficit just means rainfall minus evaporation. So like how much rain do we get? Okay, how wet is it? Atmospheric CO2 is important because plants eat CO2, they take it in and that's how they grow.
And they breathe out oxygen, right?
And then temperature matters too, right?
Yeah.
Like, you know, you don't find polar bears at the equator or elephants at the poles. And so these are kind of the things that change over time, right? The climate variables. And then on the right, we have some ecosystem variables, right? So there's fire, and if you have fire that kills trees, right, leads to tree mortality. And then you have this kind of back and forth between forest cover and grass cover, okay? And then the arrows, if an arrow pointing to something, that's a positive feedback. So if you increase temperature, you tend to get more grasses over trees, okay? If you decrease rainfall, because this is moisture deficit, you often increase grasses. And then if there's a little ball here, that's a negative feedback. So if there's high tree mortality, it leads to less forest cover.
Yeah.
So as a scientist, we have to kind of break all these things down and think about, well, how can we study the role of fire in the past? And for me, I use chemistry to do it, right? But there's other ways to do it. But yeah, I'm trying to like understand herbivory in a particular time period in the past, or fire in the past, or grass cover.
Herbivory is like herbivores.
Oh yeah, right.
Okay.
Yeah, that's like the act of a
So like carnivores would
wildebeest.
be eating meat.
Yeah, carnivores eat the herbivores.
Sorry,
Yep, and the herbivores eat the plants. That's a good thing to clarify. Yeah. So that kind of it is in a nutshell is what I do as a scientist. Yeah.
So what do you like most about your job?
Well, there are many things I love about my job. I guess first and foremost, I love trying to solve scientific puzzles.
And you're not talking about like the puzzles you get at like the natural history museum?
No, not those puzzles, not the jigsaws, like the scientific puzzles, like when did we start eating meat as a species, or when did we gain control of fire, that kind of thing. Yeah. So yeah, currently I'm trying to understand how early humans interacted with their environment and the animals around them. And, you know, I find it fascinating that early humans eventually evolved into a species, us, Homo sapiens, that changed the face of the planet so dramatically over the past few centuries.
I mean, just like looking out, there's a huge building and no tree could probably be that tall.
Yeah, we've really changed the face of the planet by all of the things we've built and consumed and that sort of thing. And it really remains to be seen where we're going as a species in the face of climate change. So another thing I love is about my job is working with other scientists.
Like as you can see in the pictures, right?
Right. These are some of my scientific colleagues. You know, I specialize in a pretty narrow world of something called isotope inorganic geochemistry. I'm still kind of nerdy, I guess.
Yeah.
But I also need lots of help in my research from colleagues who are, you know, paleontologists who study fossils, archaeologists who study, you know, process bones or stone tools, things like that, and also botanists. I work a lot on plants, but as you might know, I don't really know much about plants. And then I guess the last thing that I love about being an earth scientist is that it's allowed me to travel to many beautiful parts of the world and meet people from different cultures, also shown in these photos here.
And I actually got to go to Kenya once. It was really
Yeah,
cool, beautiful.
Even you
The
benefit.
people there are really nice too.
Yeah, yeah. So I love being able to share that with you. And I guess it's helped me realize, and maybe you at this point or maybe later in your life, that no matter where you're from or what religion or beliefs you have or how much money you have, we're all at the end of the day humans, and we all have to work together to sort of solve the current climate crisis. Yeah. So should we maybe open it up for some questions if there's anything in the Q&A?
Yeah, sounds good.
Yeah. Thank you all for attending and being here today.
Hi guys. Okay, so before we even get to our Q&A, I want to ask Max if you are available for future interviews, because I think you did such a fantastic job, and I am like, when is he available next? Because I think it's so wonderful to have students joining us on our programs, and I see a couple of fifth grade classes who are actually tuning in as well here. So I want to open it up for Q&A. And so for our viewers, if you do have any questions, feel free to type it into the Q&A box. In the meantime, though, maybe I'll get things started I'd like to ask Max a question. And Max, I'm curious, what you have learned in this process of interviewing your dad, and about what he does, and have you found that interesting?
It is really cool.
Yeah.
I don't think I'll ever be able to do that because I'm more of a present person. I don't want to think about stuff that happened 20 million years ago.
Wow.
But yeah, I think it's really cool how my dad can date like different teeth to see like what the botany or the plants were like back then. But it should be said that he does a really good job at it.
Yes. And I'm sure, I'm positive that he does. And I often think that scientists, when they study something so far in the past, that they have superpowers, and that they're able to kind of solve those puzzles, and have some kind of superpower, because that's not something that we can just see with our eyes. So I find that super, super interesting. Okay, so we have some questions. The first is from Ms. Jones's fifth grade class. And this is for Kevin. What is your favorite thing to study?
That's a hard question because I love studying so many things about the Earth and humans. I think right now, one of the things I'm most excited about studying is our ancestors' interaction with fire. Like, when did we, and I say interaction because we probably didn't start just like, we weren't walking around and just like found a match on the ground, right? We had to first begin interacting with fire, approaching it, and then maybe using it eventually for cooking. But to do that, we probably had to get control of it. So there must have been some period where humans were kind of interacting and getting familiar with fire, let's say. And I think the origin of fire humans and fire probably happened, let's say, many times around the world, whether it's early Homo in Asia or in Africa or in Europe, right? Because to get into Europe, the colder parts of Europe, we probably had to have it at good use or be able to control fire a bit. Yeah, great question.
Fantastic, thank you. The nethere question is, what's your favorite place to visit when you're doing field work? And you touched briefly on Kenya, and is that your favorite place, or have there been others as well?
Yeah, one thing I love about Kenya is it still has many wild animals like elephants, giraffes, lions, things that as a kid, I only get to read about or see on TV.
The zebras, like, one thing I want to point out is the amount of zebras we saw there was insane.
Yeah, there was a lot of zebras. Yeah, there's a ton of zebras, especially at Impala, right? But I think one of the most memorable trips I went on, and Max didn't go because there were some safety issues, to the middle of the Sahara Desert in Niger in 2019. And just to see the vastness of the Sahara. And also what we were studying was a population of humans that lived there about 5,000 years ago. And what was really amazing about it was 5,000 years ago, the Sahara was completely green, covered in vegetation. And there were people living on this lake there, which the lake is long gone. But we have, you know, fish bones and crocodile bones and hippo bones and tons of human burials there. So it's a window into a world that isn't so far gone 5,000 years ago. And I just never been to the middle of the Sahara. So that was probably one of the most remarkable trips I've ever been on. Yeah.
Awesome. Thank you. The next question is, what have you seen are perhaps some of the unique and best ways that students of all ages can go about raising awareness, climate awareness within their communities?
That's a great question. I mean, I think it starts with conversations and just learning about, you know, science and being able to talk to your parents. That's one of the big things. You know, Max and I think I probably talk about climate a lot more than most parents around the dinner table.
One time when we were eating burgers, I went into the car to go get napkins and my hands were really greasy. And I was like using a bunch of napkins and he was like, Max, only use one, use the whole thing. Fold it, use it, fold it, use it.
So yeah, we try to.
I'm really glad that Max is also chiming in with his perspectives because I think it's very real and I love it.
Yeah. So I don't know. How do you think? Do you have any thoughts on how kids can get involved in their communities? You know, working on climate or environmental issues.
One thing I would say is, I know that everyone says this: don't throw trash on the ground, because probably the nearest trash can is like 10 steps ahead of you. And in some areas of New York City, especially one area where I just moved with my mom, not even there, but like sometimes you're driving on a highway and it looks like a landfill, but like you're in the middle of a city and it's really weird.
So like personal responsibility, just like throw your stuff in the bin. Yeah.
It's the least you can do.
Yeah.
Yeah. And I think, Kevin, you raise a good point about conversations. I think we all, and I think listening to each other is also a really important piece of that. So the fact that everyone is tuning in today, listening to our scientists talk, and our scientists also spend a lot of time listening to all of you, including Max. And we learn so much from students and perspectives from younger students as well. So I think, those conversations. Yes,
what I would say to all the kids watching and adults, you can plug your ears now, is that you guys have a lot more influence on your parents than maybe you think. And so if you bring up conversations at the dinner table or on a long car ride about the future of the planet or like the climate crisis and just want to learn more about it, you know, that might help them, bring them into it, and you guys can have discussions. Maybe they can help you learn more, or you guys can, you know, sort of learn together. So I think just talking with your friends and especially with your family and your parents is important.
Yeah, absolutely. Thank you. Okay, so we have a question from Julia, who is in grade 5 in Bogota, New Jersey. And Julia wants to know, how long did you have to study before you became an earth scientist?
Well, I would say we're all earth scientists if we're thinking about the planet and you know, out there doing things to make it better. To be qualified as an earth scientist, maybe, I don't know. I think as soon as you start learning it in school about the earth, you're an earth scientist.
I think she means what graduate
Okay.
did you have to get?
Okay.
Your master's.
Okay. Okay. So yeah, after college, I went to graduate school. And that took, I was a little bit on the slow side, but that took about 7 years after college. So it takes some time, but you know, if you're having the most fun in the world, then it doesn't seem like that long. Yeah.
Yeah, great answer. This is a fun question. So do you think robots and artificial intelligence can help you in your research, or any other technology, and could potentially be a disruptive technology, and maybe in a good way?
Yeah. So, I mean, in the lab, we use instruments and technology for everything. That's how we make these really precise measurements of isotopes and things of very small quantities of material. So we certainly rely on technology and instrumentation. And as far as like robots and AI, we use remote sensing products like satellites flying around, circling the Earth. We sometimes use drones to map areas and take photos. The drones have just come so far in the last few years that you can just collect, vast amounts of data, elevation, vegetation, lots of stuff. And then I have a colleague, my colleague Rachel, is starting to use AI in some of her work. And so I don't know how to do it, but she does. And lots of colleagues, lots of folks at Lamont are digging into using artificial intelligence to start to uncover things and like how the Earth works. And so I think there's a huge future in AI and Earth science. Yeah.
Fantastic. And this is related because, so as I mentioned, Kevin is one of the scientists featured on our collectible cards. And one of the items that we chose to feature him with is a mass spectrometer. And so as an important tool that Kevin uses, there's a question here about what a mass spectrometer actually does.
Wow, that's a good question. The mass spectrometer tells you about how much of a certain type of atom or molecule you have. So I use it to look at, for example, carbon isotopes. And there's generally two flavors of stable carbon isotopes, not the radioactive one, carbon-14. And that's carbon-12, which most of the Earth is made of, most of the carbon on it is 12, and there's a little bit of 13. And the ratio of 12 and 13 in different things like your teeth or your hair or your foods tells us something about the origin of that carbon or that food. And so the mass spectrometer allows us to determine, say if we take a zebra tooth and analyze it, was that zebra a grazer eating grass or a browser eating leaves on a tree? And we know from observation that zebras are grazers, but if we want to go in the geologic past, we don't know that because we can't observe zebras a million years ago. We don't have a time machine. So the mass spectrometer allows us to investigate past environments, ecosystems, human diets by making these very, very accurate measurements on, say, carbon or oxygen or hydrogen isotopes.
So in a way, it's the closest thing we have to a time machine.
It is my time machine. Yeah. Yeah, totally.
I love that. Love that comparison. Thanks, Max. Actually, Max, the next question is for you. Do you think about a career in science yourself, or what are you thinking about? I know it's very early.
I mean, I guess I would maybe. I mean, I don't know if like doing solar energy would count, or like engineering.
Involved. Yes,
Mhm.
absolutely.
That's probably the only one I would consider. Maybe I would be like a consultant for like trying to make a business economically or and ecologically sustainable. But I don't know if I would actually want to be like a professor or research professor.
Because they work so much.
Yeah.
Yeah.
And they sent so many emails.
Yeah.
Yeah.
So much email. But you're also interested in architecture, right? Isn't that kind of one of your...
But is that science?
Totally. Oh, it's a STEM field, right? Yeah.
Yeah.
But
And
you
I think
don't have
there's
to be in STEM. You can do whatever.
you can do whatever you want.
Whatever you
Absolutely. There's also a lot of there's now such cross pollination of the different fields. And so I know a lot of architects who are at Columbia who also work on trying to build and create more sustainable, whether it's land uses or changing or adapting our environment so that we can better prepare for climate change? And if we do have flooding, how can we make our infrastructure, like our buildings, our transit systems, way more resilient? And that has a very strong architecture piece to it. So yes.
Yeah, and actually there are like people or architects that figure out ways to make very sustainable houses, like
Yes.
solar panels on the roof, and then they figure out a way to so that the windows are like insulated, but they also let in sunshine, and they're positioned in a way so that like you get the most light possible. It's really cool. And like
very
the
cool.
concrete can help cool the ground, and so I guess being an I really love architecture, so that's probably
awesome.
the biggest one I would consider, but yeah.
Awesome. Well, thank you for sharing that. Our next question. So for Kevin, how is your research funded?
Most of my research is funded by the National Science Foundation. So that's a government, federal government organization. So taxpayers basically. And, they don't just give us the money. You have to pitch an idea, like you say, where do grasslands come from? And here's how I'm going to try to find out. And then it's kind of like, I don't know if anyone's seen that show Shark Tank, but like we like pitch our idea, like this is what I want to do. And then they send it out to a bunch of like Shark Tanky people who are like, I don't know about that. Uno, like that's probably not going to fly. Or they say, that's a pretty good idea. And so they take other experts or our peers who evaluate that and then decide, yeah, that's a worthwhile scientific pursuit or not. But I also get some funding from private foundations, like this project in the Sahara Desert is funded by Columbia, actually. It's the Center for Climate and Life, or now the Climate and Life Initiative. And so that was privately donated to the university and supports that work. So, yeah.
Awesome, thank you. We have a couple questions that are species and animals related. So I wanted to perhaps combine those. So have you discovered any new species? And also, has there been a favorite animal that you love learning more about?
So I haven't discovered any new species like that are living or known to man. But for me, when I go into the museum and find a new tooth of an extinct carnivore or something that's new to me, not to science, there is a little sense of discovery of like, whoa, this carnivore we were working on these otters, for example, which are carnivores from like 3 million years ago. And my colleague, she told me, she said this otter was bigger than a female lion, which is like, I don't know, 300 pounds. So just trying to wrap your mind around a 300-pound otter that we think was less in the water and more on land and would probably go after one of our ancestors, So yeah, in that sense, I get to discover new things in museums that I didn't know before. And my favorite animal is definitely elephants. I mean, the African elephant I studied them in graduate school a little bit, and I just find them really majestic, and they've got a lot of isotope history in their tusks, which is another bonus for me. Yeah.
I also have a photo of an elephant. Did you take it? Or
do you want to show us?
It's in my bedroom, so I don't.
Okay, all right.
I could carry it. I don't.
Save that for another time.
Yeah. Actually, Max, another question has come up for you. Does having a dad who works in science, in the science field, does that give you a different perspective from your classmates in school? Do you think you certainly probably hear a lot more about field work, for example, but what do you think about that?
Some of my classmates, some of them are like just as nerdy as me.
Wait, you're nerdy too?
Oh. Sometimes. But it does give me an edge sometimes, but I'm at the age where kind of like it doesn't really matter if your dad is a scientist. I mean, it helps, but like some of my other classmates do know as much, maybe even more about science than me, just because they're a lot more interested in science than me.
Yeah, but how many of them have actually done an interview
Yeah.
on yeah, right.
That's interesting.
Awesome. Yes, totally. Great. So the next question, we've got 2 questions left here. One of the questions is, have you ever found a tooth from our ancestors?
I'm actually a pretty crummy fossil finder.
Okay.
I go to fossil sites and nodding there. Um, and I collect sediments and sometimes look for fossils, but the best fossil finders in the world are generally the local people who live in and around the places where we work. And a lot of the fossil finders grew up as herders of goats and sheep, and so they walk around as kids. You know, these usually it's boys go out with the goats for hours and hours, days and days, and so they just read the landscape so beautifully. And you'll be walking with one of them and I'll be like, you know, droning on about, I don't know, grasslands or something. And they'll just say there, and they'll see a little piece of something that doesn't kind of look like the rocks on the ground or reflect the light the same way. And they have an eye for just finding a little piece of a bone exposed, and you move the rocks away or sweep away the dirt, and you know, suddenly they found a fossil. And I've been there for discoveries of our ancestors' teeth or bones, and it's always just really exciting, especially if it's a new species or something. But I'm generally not the one finding and discovering these things, but I might help analyze it.
Sorry, can I add on to that?
Sure.
So for anyone here that knows, like was it the clay army in China?
Yeah, the terracotta.
That wasn't found by like an archaeologist. That was found by a farmer who was going to dig his well there, which I find kind of interesting.
And that's a great point. In fact, one of the most recent hominin skulls, like the skull is like, you find a skull, it's like, whoa, big deal. And a new species was found. I think it was published a couple years ago, but it was found by a farmer or a goat herder who was out walking, was like, something's different here.
Something's off.
He contacted some locals, some experts, and he found a new species in our lineage. Yeah, just a
Awesome.
regular citizen. Yeah.
Yeah. Thanks, Max, for adding to that. And so our last question here, other than sort of industries generating electricity from renewable sources of energy, what other industries or perhaps developments do you think Earth scientists or Earth science can grow on a larger scale in the next 20 years? So maybe what we foresee might change in Earth science as maybe new topics or areas of study, what's exciting, what's coming up, and what's cutting edge?
That is a really fantastic question. I mean, I think we're going to really need to understand very quickly and at much finer scale how the Earth is operating in terms of the climate system, like the carbon cycle, because we're producing a lot of extra CO2 and that's warming the planet. And so there's some talk of carbon sequestration by sort of anthropogenic means, like we sequester it, but also understanding what the natural sources and sinks are, so that we kind of can see where we're heading, because that's an immediate challenge for us. I think kind of tying it back to like architecture and design, like how do we make smart cities that are going to be resilient for extreme rainfall, hurricane, storm surge, that kind of thing. And so that maybe isn't exactly classic Earth science, but you know, we need Earth scientists who can help us understand, you know, how can we use things like mangroves or other, you know, plants to soak up some of the stormwater or reduce the storm surge, that kind of thing. So there's just so many different options in the field of Earth scientists where people can pitch in.
And I think another thing that a lot of us don't want to grow, but that has the possibility to grow if we don't stop it, is the fossil fuel industry. They were campaigning for fossil fuel to be in the $1.4 trillion infrastructure plan. And those companies have a lot of money, and a lot of the time they can kind of buy off politicians. And then that leads to policies that will actually help the fossil fuel industry grow, even though a lot of us don't want it to grow. So that's one industry, in my opinion, that has the possibility to grow, but that maybe we don't want to grow.
So that maybe brings it back to one of the first questions. What can kids do? Write a letter to your congressman, to your senators, wherever you are, and say, hey, let's find a better way to power our lives. Yeah. Good point.
Yeah. And I think that's a really nice way to wrap up and sort of come back to the idea that everything is a system, and what we do in one place affects somebody else. So what a policy might get drafted and made and turned into law or action, and then that results in something else, and that results in something else. And so I think it's really important to just remember that all these pieces are connected. So before we wrap up, Kevin, if you could stop sharing your screen, I'm going to share just a quick overview. So here's the card that Kevin is featured on, and we have packets of these, and there's 9 scientist cards in this series, along with an empty one for everybody to draw yourself as your future scientist, or as your future, whatever you would like to be in the future. And these are available on the same site that you had registered to attend this event. Tomorrow at 11 a.m. Eastern Standard Time, we are going to have another Meet the Scientist session with Kailani Acosta, who is currently a PhD candidate in the Department of Earth and Environmental Sciences at Columbia. And she's going to offer a very different perspective of her work, and she works mostly in water. And she's an oceanographer, and she primarily works in the U.S., I believe the Gulf of Mexico is her primary area of focus. So please tune in for that as well. Max and Kevin, do you have any last words you want to share with our viewers?
Not really. I just want to thank you all for being here and getting me out of school for 2 hours.
Well, I hope your teachers will watch. You can send this video and say that we gave you permission to do it. Kevin, any last words?
I just want to thank you, Max, for joining today. Thanks for pitching the idea of doing an interview. Yes. I thought it went well. Cassie, thanks for inviting me. And I hope you all can attend Kailani's Meet the Scientist tomorrow, which is going to be awesome, I'm sure. And thanks for joining today.
All right. Well, thanks, everybody. Thank you, Kevin, and to Max. And we hope that you enjoy the rest of your days, and let us know if you have any additional questions. Thanks, everyone. All right. Bye.